Hello, Michael. Let's go ahead and get started. Hello, everybody. Why don't we go ahead and say our names and affiliation? So Shlomo
I'm Shlomo Novotny with Segwenta.
and Gert
I'm Gert Svensson from KTH in Stockholm.
Todd
Todd Tacken from IBM Research in Yorktown Heights, New York.
Oh, welcome. Brian
Brian Webb, Pittsburgh Supercomputing Center.
Greg
Greg Barrett from Cirrus in Johannesburg, South Africa.
TJ Oldham. Sorry, I don't remember.
Natalie, my name is Tim Oldham from Mississippi State University.
Oh, okay, great. Wonderful. Norm, hello.
Hello, it's Norm Ross at Lawrence Berkeley National Lab.
Christian. Christian, you want to say hello? Oh, looks like he dropped actually. Okay, Aisha,
Hi,
want to introduce yourself? Just say your name and affiliation.
sure. Ayşe Coşkun from Boston University. I'm a professor. I work on energy efficiency and high performance computing analytics using machine learning.
Great. Christian, want to say hello? Somehow, Christian, we're not hearing you. Sarah,
Hi, how's it going?
good. Do you want to say who you are and what your affiliation is for us?
Yeah, that sounds lovely. So this is my first time being on this call. So might be helpful if there's context I didn't leave out that or I left out that's not relevant. But I am Sarah Hitt with ChemTreat. What we do is the actual liquid itself and the liquid cooling and pretty much consulting around that. Our bread and butter has always been the cooling tower, chiller treatment, and we're expanding a lot into the liquid cooling, understandably, with the growth and the expertise that it requires, the level of detail. So it's quite exciting, and I love to chat about it. So let me know if there's anything pertaining to that on the chemistry side that we can support.
Excellent. Thank you. Let's see. Irfan, you want to say hello and your affiliation?
Yeah, my name is Irfan Elahi. I'm the division director at the National Center for Atmospheric Research. And my division operates the data center in Cheyenne, Wyoming. And we also manage the Derecho supercomputer, which is an HPE cluster for Earth system science research.
Excellent. Let's see. Brandon.
Good morning, everyone. Brandon Biggs, Idaho National Lab, just here to listen to see what everybody's got going on and learn some things. So
Great.
thanks.
Yes, thank you. Thomas Silsha.
Hi, this is Thomas from TU Dresden and the group defining the measurement methodology.
And Christian. Let's see if we can get you this time.
Successfully. Hi, Christian from RWTH Aachen University.
Excellent. All right. Well, welcome everybody. Thank you for attending the general membership meeting for the Energy Efficient High Performance Computing Working Group. And we normally just start with general announcements. So before we meet again, which won't be until October, the EEHPC Working Group will be hosting a workshop at Cluster, which is being held in Kobe on September 24th. So that's a general announcement. Does anybody else have any announcements that they'd like to make? Okay. So let's go ahead and dive right into team updates. So Gert, you want to tell us about the procurement team?
Yes, lately we have been working for a long time, or for at least a year now, I think, with introducing sustainability in our procurement document. So our output is mostly the procurement document, where we define different requirements you can write and give you ideas about in the procurement to make the system more energy efficient. And now we have decided to introduce a general section about sustainability in the broader sense than just using less energy. So we are talking about CO2 emissions and other kind of things you can do, and we are trying to write some general statements and requirements for that. And at this time we are reviewing some ideas we have and discussing and get things together so we can publish the document soon. So we have quite fun, so if you are interested in the subject, please join us.
Thank you, Gert. Any questions or comments? Okay, great. Michael.
Hello. So update from the ODA team. Let's see. So we submitted a Birds of a Feather proposal to SC24, mostly focusing on analyzing the data we're collecting on our HPC systems with AI, but also a non-AI method. So we felt that we should stress a bit that it doesn't always have to be AI, and there's other powerful methods that might be less complicated. So that's kind of the theme for the BOF we proposed. Also stressing a bit more on how this BOF will help our community building. I think in the last couple of iterations we had for this BOF, we actually attracted quite a few new members to our team. So would like to continue this. Then also during the preparation of the BOF, we kind of encountered the topic that after the BOF sessions or during these sessions, we are often also approached by newcomers to the field who would like to get some advice on where to start and kind of best practices and so on. So we figured that we should work on such guidance, so maybe a best practice guide. Also, we floated the idea to maybe have a tutorial at one of these conferences, maybe at SC or at CAC, the Cray user group meeting. So no concrete plans yet, but we will revisit it during one of our next meetings and see what we can do. Our last meeting in July, we continued the brown bag presentations we had in the past. So basically sites coming in, presenting what they're doing in terms of ODA. So last time we had Jan Eitzinger at the German data center at the University of Erlangen. So he presented on Cluster Cockpit, which is monitoring and an analysis tool that focuses more on the job level. So it gives an interface both to sysadmins, but also to users of HPC resources to have deeper insight on how the jobs are performing. That was quite well received. I think he will come back this week in our ODA meeting to continue the Q&A on Cluster Cockpit, since we ran out of time last time. Also, we will have Christian Wassermann from WTH Aachen to present what they are doing in terms of monitoring and ODA. So that's the meeting on Thursday at I think it's 9 a.m. Pacific, 6 p.m. European time. And then the meeting afterwards, which will be on September 12th, we will have presentation by Ryan Grant on recent developments in Power API. So Power API is also including cooling controls now. We will discuss a bit on how we can leverage this. Okay, I think that's all I had.
Thank you, Michael. For anybody who doesn't know, ODA stands for Operational Data Analytics. So that's the ODA team. It is a well-attended team with a lot of really interesting presentations, the brown bags. That's a very cool approach. So any questions or comments on ODA? Okay. Thomas, you want to tell us about power measurement?
Yes, so in the power measurement methodology group, as you might know, we are trying to make an update to the methodology that is behind the Green 500 and therefore the energy measurements for the top 500. So this is quite a big effort. We've got a lot of requirements already in. We've had good buffs about that. In the recent past, we have focused on the submission process for the top 500 and trying to integrate a review of the energy measurements in the submission process to be a little bit more flexible in the definitions and the requirements, and not so much to scrutinize the numbers, but more to help submitters to go over a threshold when they don't really know what level they should choose. And then we had two very interesting sessions also with the colleagues from Aachen University that presented their challenges for doing a Green 500 submission. It was very well prepared, and it adds to our list of things that you want to update, and also reinforces some ideas we already had for an update. So we kind of have the urgent need to progress the document, but yeah, that's will be in the next steps.
Thank you. Any comments or questions on that? All right. Okay, so Michael mentioned, so I'm going to give a brief update on a couple of other teams. One is the Power API team. So Michael mentioned that the Power API has expanded its scope from just HPC systems, sort of the compute and memory systems, to include cooling systems, and particular CDUs. And so we have finalized a proposal within the team and are now ready to take it out for more public review. And we're going to start with the ODA team, but beyond that, there'll be a general call for review. We'll probably do it as a webinar, but make sure that we get all the Power API people there, people that are actually voters for the Power API. That is a community standards body. And people sign up to participate and then have a vote as to what gets accepted or not. So, so anyway, that's the Power API team. There are a few other changes that are being made to the Power API, but they're pretty nominal, actually. Does anybody have any comments or questions on the Power API team?
I guess I could just kind of have a general question. It's exciting that it's kind of being expanded like that. I guess there's a lot of different options for like cooling infrastructure still. I mean, is there like the first initial things that you're looking at? Like, is there a specific company or anything like that, or is it just kind of like generally what's available now? I guess is what you're focusing on with that scope expansion to Power API.
Well, Brandon, that's a good question. We are definitely vendor agnostic in the Power API. And although we are, looking for, people that will take it, and I've forgotten the word, there's a specific word, but basically take it and implement it, and then open up what they've done potentially to the public. But the vision in the work that we've done includes sort of short end things, immediate things, which is, the controls that are pretty much already implemented in CDUs that are used by the facility and exposed in a standard way to the facility. But it also, though, it definitely, the motivation behind it is for implementing more sophisticated cooling control mechanisms that would, because the Power API deals with, all the stuff inside the system, including job data. So some sort of, as well as, like power data, for instance. Cooling controls typically don't trigger off of power today. It's not their indicator. But that's a more leading indicator than what they do trigger off of today. So the idea is that there would be some predictive capabilities so that the cooling system could adapt in advance to demands placed on it by the compute system.
That makes sense. Thank you.
You bet. Okay. The another team that I'd like to report on is the liquid cooling how-to team. So the liquid cooling how-to team wrote a white paper and posted it on our website in October of last year. Well, they actually took that paper and submitted it as a scholarly paper. It modified it slightly and submitted it as a scholarly paper to the Sustainable HPC State of the Practice workshop. And it was very well received and is one of the accepted papers. And so that team is going to have a published paper. The same people, I reported this in June and we haven't actually made any progress, but we do have some plans now. So the same people who wrote that how-to guide for liquid cooling, sort of, what are the first steps, kind of like what Michael was saying for ODA. They're looking now at TUE and what are the first steps for measuring TUE. And we had a great report out last time from both Dave Sickinger and Norm Barassa, who's on the line today, about TUE, and it's in the minutes from last time. So, so if you wanted to read more, you could get more information there. But we are looking at doing a how-to guide for TUE. So that's a new team activity. And then beyond that, we are still looking at the case study from Oak Ridge for cooling controls. And there was a little bit of discussion after our workshop in June on that paper. So it brought it forward a tiny bit, but very slow progress, but still intending to write a case study on cooling controls at Oak Ridge. Okay. Now I'm going to open up the floor. I know that there are a few people like Aisha who asked for some time. And so I'm going to open up the floor and then I'm going to end with a conferences update. So Aisha, please help yourself. And if there's anybody else that has things, we have lots of time this morning or today, we can spend a little time letting people know about things they're working on outside of the EEHPC working group, but relevant to this community.
Hi, I'm Aisha, and I wanted to give a quick update on the work we've been doing related to operational analytics. We've been applying machine learning to automate performance anomaly diagnosis, basically to determine problems in high performance computing systems. I can share my screen and so that there's something to look at. Can you see my screen? Yeah.
Yes.
Okay. So this is a project between my team and Sandia National Labs. So like I mentioned, we've been applying machine learning for automating computer system analytics. And so our work started with this idea that we can use collected telemetry data. This telemetry data is in the form of time series data, can be collected through infrastructures or systems like LDMS or any time series telemetry system, basically. And then if we have labeled data that points to different types of anomalies like memory contention, IO problems, memory bandwidth problems, CPU overload, and the like. And then we can learn this behavior in a way that's agnostic to the applications. And that's the offline training part on top. And that at runtime on each node, we can run our machine learning model and predict if there's if everything is fine or if there's a particular type of anomaly. In this example, it's showing that there's a memory leak, for instance, on a particular node. So to create this machine learning model, we designed an anomaly suite and implemented different types of anomalies, stressing different types of subsystems like CPU, memory, network, IO. And then generated synthetic anomaly data basically when running a variety of applications. And this type of approach gave very good results in detecting and diagnosing the anomalies. The difficulty here was going beyond merely anomaly detection, but basically pointing out to the root cause of the problem. Now, this got some visibility and we got good results, like I mentioned. But later on, the obvious issue here is that one can use our synthetic anomaly suite. However, if you want to train models based on real-world data, then labeling becomes an issue. System administrators may solve problems and label some data, but the amount of labeled data is very sparse, if any. So we changed our method into doing anomaly diagnosis with much fewer labeled samples. And in this case, we designed this framework called Albatross. And this is open sourced in our GitHub repository. The link is on the bottom of the slide. So we start with an unlabeled data set. Again, this is telemetry data collected from all the nodes. So per node, there are typically hundreds to thousands of metrics. We do some feature selection to reduce this data set, and then further feature selection to convert these into statistical lumped measures, basically to make it more efficient and more accurate. But this essentially is the same kind of data set as before. This data set is getting into a module, an active learning module, where there's potentially a human annotator. And then through a small amount of labeled data set, a machine learning model is created. And after iterating on this model, basically the job of the active learning model is to determine, the active learning module is to determine what data should be looked at. And so this can be done randomly, but then it would take a long time. By using active learning, we determine which data should be looked at first to do some labeling. And in this way, we iterate through this, and then if we believe there's sufficient iteration, either upon reaching a target or upon doing this a certain amount of times that's predetermined, then we stop the training and we have a model to do predictions. So when we do this approach compared to the fully supervised approach that I just mentioned, there is about 30 times reduction in the amount of labels required, even in the most efficient case. To reach a high F1 score for accuracy broadly in prediction, we would need 5,000-6,000 samples. It can be much more, but like in the most efficient case, we did downsampling, etc. It's to reach an F1 score like that in the fully supervised case, several thousand samples are needed. With this approach of using the active learning module to determine what to label, we reduced that to 75 to 200 samples, which is a much more reasonable amount of labels to have as opposed to thousands of labels to train a model. So the assumption here is that there's a lot of telemetry data that's unlabeled, but over time and over basically showing what to label to human annotators who could be system administrators or users, we can create a relatively small labeled data set and then a machine learning model that's as accurate as a fully supervised hypothetical model. And then our last paper on this, we have ongoing work, but last paper that was published was at Supercomputing last year, looked into anomaly detection in absence of labels. So no labeled data sets. We only have the telemetry data. And we wanted to do this because a lot of systems are in this situation. Of course, this removes the ability to identify the specific anomaly. So because we don't have labeled anomalies, then we can't really say what was wrong, but we could, with high accuracy, determine if there's an anomaly in a large telemetry data set. And how we do this is we collect, again, telemetry data for each application on each node of the application. And in an offline feature selection stage, we basically determine the most efficient features. And then we basically use a variational autoencoder training that learns the behavior of the healthy data, and then we create a model based on that. So this kind of framework is capable of looking at large data sets across different applications, different input decks, including applications that the system hasn't seen before. As long as there is a good training set initially, then even if new inputs or new applications come in, it can still detect anomalies. And we use the supercomputers at Sandia, the Volta, which is a testbed, and Eclipse, which is a production system, and achieved high F1 scores on detecting anomalies. We also designed a framework to deploy this, to do this anomaly detection at runtime. And we've done this on the production system Eclipse, and we provide details on how we did that in the paper. The reason I wanted to give this update today is that all of this code is open source, and we've been working with it for several years. And we have some ongoing work right now to make this Prodigy framework more robust and applicable. We are welcoming feedback, use cases, interest in deploying to different HPC clusters or supercomputers. So any feedback and collaboration opportunities are appreciated. Thanks very much.
Thank you. Any comments or questions? Well, really interesting work. Thank you very much. That's great.
Thank you for the opportunity.
Okay, we have a few more people on the line. I'm going to let them introduce themselves. So just your name and affiliation. Beste. Beste Ostap.
Beste and Efe are my PhD students. They might be joining from the lab.
Okay, all right. Great, thank you.
Hi, hello. Sorry, I couldn't find where can I unmute myself. I'm Beste. I'm a second year PhD at Boston University, and I'm working with Ayşe Coşkun.
Excellent.
This is my first meeting, actually, so hi, everyone.
Hello. You're welcome to join the EEHPC working group, if you haven't already. So
thank you.
Yes. Okay, Brandon Hong.
Hi, my name is Brandon Hong from Lawrence Livermore Lab.
Welcome. And then Efe, want to say hello?
Hi, everybody. My name is Efe, and I'm a PhD student at Boston University working with Professor Ayşe Coşkun.
Oh, welcome. Again, you're welcome to join the EHPC working group and get notifications and minutes and all kinds of things. Okay. Anybody else that has anything for the good of the body that they'd like to announce or talk about? All right, then I will give an update on conferences. We have 10 papers that have been accepted and will be presented at the Sustainable HPC State of the Practice Workshop in Kobe on September 24th. And I'm just going to read the titles. So PowerSCED, Managing Power Consumption in Over-Provisioned Systems. A how-to guide for transitioning from air to liquid-cooled high-performance computing systems. Optimizing idle power of HPC systems, practical insights and methods. Calculating user-centric carbon footprints for HPC. Evolving large-scale HPC monitoring and analysis to track modern dynamic environments. Microgrid integration with high-performance computing systems for microreactor operation. Power efficiency variation on A64FX supercomputers and its application to system operation. Towards improving resource allocation for multi-tenant HPC systems, an exploratory HPC cluster utilization case study. 16 years of spec power, an analysis of x86 energy efficiency trends, and advanced visualization of power, temperature, and energy metrics in HPE Cray EX systems. I want to thank all the reviewers and the authors for their amazing contribution in helping to make this happen. And I know some of the authors, there's at least one author on the line, so I welcome you to speak up about your paper. If you want to. I won't put you on the line.
Yeah, thank you. Yeah, I'm really happy to be accepted. So my first paper as a first author. So yeah, I'm excited to see how the presentation will be accepted, and I'm excited to talk to you all who will be joining the workshop and discuss in person about the carbon footprint methodology we developed, and yeah, how it can be generally applicable to multiple clusters. Yeah, excited to talk to you all.
Thank you. Anybody else?
So I also have the idle power paper that you mentioned. Maybe I make a very quick pitch. I think idle power is actually a relatively important aspect because there is a huge gap between what you can achieve and what we see in practice on the HPC systems in terms of how much energy we use in idle. And I feel like systems are idling more than we are happy to admit, because we all want our systems to be utilized all the time. But in reality, there are lots of downtimes due to scheduling issues before large jobs, or due to just maintenance stuff. And I think there's a lot of real energy to be saved in idle power, and I would love to exchange with you how you deal with it on your side, because when we looked at this at our side, we were very surprised about the factors that impact idle power consumption, and the scale of the impact from these factors. And so would love to see more data from other centers, because that, most of the energy optimization is just focused on application power. And I'm also a co-author of the spec power trends paper, which is really cool. Daniel's going to present it in the workshop, and this is interesting because we kind of in terms of very long-term trends, we actually look a lot to the Green 500, but the spec power data also has very interesting power data, even though there is some limitations in how much it applies to HPC. I think we can learn a lot from the architectural trends, and there are still things that we can see in the data, but we can't fully explain. So I think it's also a very interesting topic to discuss and to see where we will be going and how we should design benchmarks to make better prognosis about the future and better understanding of how technology develops over time.
Great. Yes, I'm very excited about this workshop. I really think it's going to be very interesting. Is there anybody who, other than Christian and Thomas, and I think Gert, I mean, is there anybody, can you just sort of raise your hand if you're planning on attending cluster and the workshop? I'd be interested in knowing. Right, Norm, yes, that's great. And they're fun, fantastic, yes. Okay, great. Thank you. Okay, so in addition to that workshop, part of the reason I was asking is we have an invitation only workshop at RECON for a day and a half before the cluster workshop on Tuesday. And we are going to have, that's all a symposium. It's invited speakers and tours. And it's a way to spend time together, extended time together, and develop relationships and collaborations. So we could potentially host a couple more people if there was somebody who can make it to cluster and wants to go to the sustainability or Sustainable HPC State of the Practice workshop. So if you're one of those people, you happen to be able to go, please let me know. And then beyond that is supercomputing. So we have a booth, of course, at supercomputing. We have a panel that's already been accepted on sustainable supercomputing. And the panelists are, well, Dan Reed is going to moderate the panel, and then Andrew Chen is one of the panelists, and Nick Dubé is one of the panelists. Thomas Eicherman from Jülich is one of the panelists. Satoshi Matsuoka from RECON, and Jenna Waldvogel from Los Alamos. So that should be an interesting panel. We'll probably have a greater focus this year on water. We barely touched it last year. So there'll probably be a focus this year on the broader sustainability issues. And we also have a workshop on Sunday. It's a joint workshop. It's we've combined the EEHPC is combining with the organizers of a workshop last year called Sustainable Supercomputing. We just closed the paper submission. And actually that paper, there were 20 papers that were submitted to that workshop. So we have a lot to choose from. So that'll be very full. But we will also have a symposium aspect of that workshop where we'll have, at a minimum, Idaho National Lab come in and talk about their goals for carbon neutral site by, I think it's 2032 right now. So how did they come up with the goal? What are their plans and what is their progress? That's beyond HPC. It's the entire site, which is quite large, has a lot of different kinds of facilities, but we'll dive down on how sites are actually executing to try and reduce their carbon footprint. We might have time for other invited speakers, but at a minimum, we'll have Idaho National Lab. And then we have submitted several birds of feather for SC. We don't yet, we should know this week or soon what's been accepted and what hasn't. But so we've got those as well. And then beyond that, we are intending to have another showcase this year. And Brandon, we're hoping actually that Livermore and El Capitan could be the showcase site and computer for this year, but we'll see how you guys are doing before we make that final decision. So I think that pretty much covers it for conferences and workshops updates. Since we last met, we held our EEHPC working group virtual workshop. That was in late June, and all the recordings and presentations are posted on the website. So Christian, it looks like you have a question.
Yes, I was wondering for the SC workshop, as I always find these recordings quite useful. Will these workshops at SC also be recorded or not?
You know, that's a question for the supercomputing, and I don't actually know. I mean, in last year, I know they had a virtual registration. You had to pay for it. Does anybody else know? Maybe Michael, do you know?
No, no idea. But I mean, recordings of in-person sessions are always a bit tricky.
Yes, I don't even know that they did a recording actually of the workshops last year. I think they did the panel. I know they did the panel, and I know they did some other things, but yeah. But I actually, yeah, I don't know if there
Okay.
were. Yeah, even by the way, Christian, we will not be able to record and post at Cluster, unfortunately. We could potentially, by the way, have webinars where we repeat the presentations that you guys make. We could do that as part of the EEHPC working group. And then record the webinars and post them. So we can get around not being able to record at Cluster itself.
I don't know if there's interest from other people.
Yeah, we could find out. We could see. I'm sure that there would be some interest. I'm sure there are people that would have liked to have gone, but the travel is onerous, either financially or time-wise or lots of other reasons. Okay. Any other questions or comments? All right. Well, thanks, everybody. Great meeting.
Thank you.
Bye-bye.
Bye-bye.
Thank you.
Thank you. Bye.
Thank you.
Thank you. Bye-bye.